discussing automatic load frequency control of single area system. In case of automatic load frequency control, it is also known as AGC, ALFC or AGC. ALFC means automatic load frequency control and AGC means automatic generation control. So what is the basic idea behind this? If somehow the speed or frequency deviates from normal speed or nominal frequency, then this automatic load frequency control will control the speed or frequency. So here we have this input as well as this input. There are two inputs. If suppose I increase the value of speed, or somehow the value of speed is increased, then what will happen? In that case, these two fly balls, they are rotating and this shaft is attached with the main shaft of generator and turbine. So if the speed is increased, they will be stretched, further stretched. If this is suppose fixed, and they are stretched because of increased centrifugal process. If it is stretched, these fly balls are stretched, then what will happen? This is fixed at this location and this is a single link. This will go down, this is fixed, this will go down and this goes down, then what will happen? In that case, if this is fixed, this goes down, this will also go down. And if this goes down, this will also go down, and then high pressure oil, that high pressure oil will be injected in this direction. Okay, this is basically hydraulic amplifier, and this will be injected in this direction, as a result of which this main piston will go upward and this thing will be closed. Okay, or opening of this steam will be reduced, as a result of which what will happen? Less fuel or less water will go to the turbine, and as a result of which our power, turbine power will be reduced. And if turbine power reduces, that means now the frequency was increased and now this power, input power to the turbine is being reduced, so the frequency and the speed will go down. Okay. And similar, but in opposite direction, the action will happen if somehow the speed reduces. And when the speed will reduce, suppose the load is more and turbine power is less. We are generating less electrical energy, but the demand is more. In that situation, the increased demand, from where that increased demand will come? That increased demand will come from the kinetic energy, as a result of which the speed will go down. And if the speed goes down, then what will happen? The stretch of this spring will be reduced. In that case, if this is fixed, this will go in upward direction, this will go in upward direction, this will go in upward direction, and the high pressure oil will enter this hydraulic amplifier from here, and this will push this piston, main piston, in downward direction, and as a result of which more steam, this opening will be increased and more steam will pass through this passage, and as a result of which the turbine power will be increased. So from where the whole process started, because we were having the less turbine power but more demand. Now this turbine power will also be increased, so there will be a balance between input power and output power, turbine power and load, that will be maintained again, and as a result of which the frequency will be maintained. Again the frequency will be increased. Okay. Another input to this speed generator is this reference input. So if we intentionally want to increase turbine power, we have to move this in upward direction. So there is a gear system, a motor is attached with this, and nut and bolt system is there. So if we rotate this thing in order to lift this thing in upward direction, then what will happen? If this goes in upward direction, then this will lower the turbine power. And if this goes in downward direction, if we want to increase the turbine power, this thing can be pushed in downward direction. So if this goes in downward direction, this is fixed, this will go in upward direction, this will go in upward direction, and the oil will enter from here, more opening will take place, and turbine power will be increased. That will happen if we increase the turbine power from this reference setting. And this is not basically done manually, this is done automatically. So the frequency is sensed again, and this actually forms the secondary loop. Actually this is primary loop, and as a result of secondary loop, it will sense the frequency deviation, and for the fine adjustment of the frequency deviation, this thing will also be controlled. And this will not only depend upon the frequency error, this will depend upon the tie line power also. How much transaction has to be made between this control area and the knob and control area through the tie line. So this is the mechanism of working of this speed governing system. This is basically primary ALFC loop.